Hi guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So in this specific discussion, we're going to look at the properties of a summation. And this is going to be adding up on our last discussion we had on, of course, the concept of the summation notation. Now in our previous discussion, I had mentioned that if we have a range of measurements for x or observations, x1, x2, x3, and of course this is going to go on to a value of x to power n. Now from the summation notation, we said that we can represent these various measurements in terms of the total number of observations by giving it a general notation, whereby each of these specific notation can be given in terms of xi or x sub I given as such. So in this case, I can of course then therefore give this specific summation of these observations as x1 plus x2 plus x3, and this is going to range on to a last value that we have given, of course, of our x n given as such. Now this can be given as a sum, of course, which is represented as the summation from I is equivalent to 1 or equal to 1 to a value of n. And this is going, of course, to constitute the general values of x I given as such, and this is going to give us the sum, or perhaps I can just give it, so this is going to give us the sum of all those values of x or observation between x1 to xn given as such. And this, of course, gave us the general representation of the summation notation, which we had discussed in our previous video. So in this case, we're going to look at the properties of the summation and try to see what are some of their properties which are going to be applied in our subsequent discussion. So one of the properties of the summation that we're going to see is that if we have the summation from I equivalent to 1 to a value of n of a particular constant which is given as k, so this is going to be represented as n k given as such, whereby I've said that basically the concept of a k implies a constant given as such. So this is one of the properties of the summation that we're going to come across. So in case we come across an operation which is going to be encompassing this aspect of a constant, then we're going to treat it as such. So secondly, we're going to look at another property whereby we have the summation of I equivalent to 1 to a value of n given as a constant ki xi given as such. So this is a product of xi, which is a general representation for various observations, and then we're going to have a constant given as such. So this is going to be given in terms of the summation, or basically it's going to be given in terms of the product of k and the summation of I1 to n of a value xi given as such, and that is going to be the way we are going to treat of course values which contain this summation sign with a constant product of a constant given as such. So suppose we have another representation of a value of the summation from I is equivalent to 1 to n of values of a plus b xi. So this constitutes two constants of a and b, and of course we're going to see that this specific constant for b includes this value for xi, and this is going to be given in terms of course the sum of na plus the summation of this specific value. So in this case, the second aspect of this value is going to be analogous to this one. So therefore, we're going to treat this p as a constant and bring it out of this summation sign. And the rest, of course, is going to be represented as I n x I given as such. So in case we come across, of course, a representation which is going to be appearing in this specific format, and this is how we're going to evaluate that specific representation. So next, we're going to look at the summation of the sum of two numbers, whereby we're going to have I, or two specific or unique observations, where we're going to have this one given in terms of xi plus yi. So for us to evaluate this is also going to be the summation of those two specific, of course, observations, unique observations, whereby we're going to have the summation from I to 1n of xi plus the summation from I1n of yi given as such. So in case we come across such a kind of a summation, then we're going to treat it or evaluate it using that specific representation. Now, what if we come across, or suppose we come across a product, a summation which is entailing a product of two specific observations or two unique observations For instance, if we have this one as the summation from I equals to 1 to n of these two specific set of values times yi. So this one is going to be given in terms of the product of xi times yi, or of x1 times y1, and then of course this is going to be plus x2 plus times y2, and this is going to go on using that specific addition sign plus the last of course set of values for the product of xn yn given as such. So in case we come across a product of these two specific range of unique observations for x and y, then this is how we're going to treat that specific summation using the representation which I have given on the board. So we can just do perhaps an evaluation of a few examples of what we have mentioned using the range of values which I've given for the set of observations for x and y which are appearing on the right side of my board given as such. So suppose we have a summation of I is equivalent to 1 to 5 of xi. So in this case, we're going to look at the values which of course constitute the element of x, which are of course are going to appear in terms of 1, 3, 5, 7, and 4. And of course, in order for us to evaluate this specific summation, then therefore it's going to be a sum of 1 plus 3 plus 5 plus 7 plus 4 given in that case. So we have added all the values ranging from the value of I is equivalent to 1 to 5, which is of course a 1, 2, 3, 4, 5 given as such. So these are unique observations up to the fifth one. So the sum of this is going to be 9, 16, which is basically 20. I hope my evaluation is correct. So this is 9, 16. Okay, that's correct. So therefore, this is how we're going to do the specific evaluation. Now, suppose we have the sum of the values of y as well given in that specific order for this substitution. Then therefore, we're going to add the values of y using those specific representation. So suppose we have the value of the summation. So this is the first case. So suppose we have the values of the summation from I is equals to 1 to 5 over a specific constant, perhaps 7. Then therefore we're going to have this one as the product of, as I said, the summation of I is equals 1 to n over value, of course, which we are given in terms of a k. This is equivalent to nk. So basically the value of n in this case is representing 5, and the k is representing 7 in that specific case. So this is going to be 5, the product of 5 and 7, which is 35 given in this case. So that's how we can use the, of course, the summation of a constant given in that particular case. So we're going also to treat other values of this specific representation using the various rules which I've previously mentioned to find values of this specific concept of summation, and that's going to entail some of the properties of the summations which we have of course discussed in this particular case. So check our description boxes and kindly subscribe so that we can be having a healthy discussion on various topics in mathematics, chemistry and physics, biology and other related topics. So in this case, I'd like to request our members to kindly check the link which I'm going to put in our description box. It's going to contain a range of videos which basically are going to be videos under the same topic or discussion. So that's it for now, guys. Bye. God bless you. Catch us in our next video.